Hey, welcome to my power presentation. Woo! Okay, so I've decided to calculate the power required to flip a drumstick straight up in the air. I already get berated for doing this so much in band that why not find out how much energy I've wasted doing it. I've asked my friends how many times they think I've flipped a stick during my 6 years as a drummer. They all said about 1,000. Each one of those flips could be anywhere from 1 to 7 feet up in the air. So if each time is different and the time that the stick's in the air is variable, how do we measure what we need? First, let's take a look at what we do need. Power's formula is power is equal to the change in energy divided by time. We can easily measure time, but what about work, the change in energy? Easy, just use the law of conservation of energy. I'm pushing the stick upwards while gravity is pulling it back down. Changing the height of the stick takes force and energy, and that energy is what we use the law of conservation of energy for. By throwing the stick upwards, I'm giving the stick kinetic energy. That energy overcomes gravity and the stick moves upwards. But at the top of its arc, all the kinetic energy has been converted to potential energy. The law of conservation of energy says that without any work done on the stick, its initial kinetic energy will equal its final potential energy. Of course, smart people can't do anything without confusing math, so the law's formula states that the initial energy plus work equals the final energy. But we can further break this down into the different forms of energy. Kinetic would be 1/2 mass times velocity squared, and potential is mass times gravity times height. We can easily fill in the mass of the stick and gravity. But what about velocity and height? There's a difference between the initial and final. Our initial height is 0, but our final height isn't. Our final velocity is 0, but our initial definitely isn't. To find these, we'll have to use different equations. Let's take velocity equals initial velocity plus acceleration times time squared to get the initial velocity for our kinetic bit here. Looking at the upwards curve of the stick's flight, we can start to fill in some values. Our final velocity will simply be 0, and our acceleration negative 9.81 meters per second squared due to gravity. To get time, we actually have to take the video and count the frames. We'll count the frames of the video when the stick is in the air. After counting 6 smaller tosses and 6 larger tosses, we can take the average times to get about 15 frames, or half a second. Solving our equation gets our initial velocity to be 4.905 meters per second. Great. Now we know, on average, how fast I'm launching the stick. We can fill that velocity into the initial kinetic energy formula. Now we have to find the height. Using the same average time and initial velocity, we can use the displacement formula. A quick punch into the calculator gets an average height of 1.23 meters. We can start solving our equation. Now that we have work, we just stick it into our original power formula. Ooh, that doesn't look like a lot. Sure it isn't. I'm only moving a pretty light stick up a few meters. But if we go back to my original statement, we're going to be looking at this one action 1,000 times. That's 5,810 watts. Household appliances like an electric blanket, a fridge, a microwave, and a phone charger use kilowatts per hour as their unit of power. My stick power is only 5.81 kilowatts. That's enough to run an electric blanket for 2.5 days. A fridge could run for 7.7 hours, a microwave for nearly 3 hours, and my phone charger for a whopping 24 days of constant usage. Wow, I've wasted a lot of energy, and even though my flip doesn't take much power. Well, thank you for listening to my mandatory screening of my power project.